Hello students and welcome back to the another video of this toughest question series, and this question is from JEE Advanced 2016, and the difficulty level according to the data released by JEE Advanced is only 1% students gave the correct answer, and it was unattempted by 80% approximately. So let's have a look at the question here. The question is, we can see this function is given and limit is n tending to infinite. So by looking at this question, it seems like it is of limit as a sum. Now, if we try to reduce into the standard form, like if I write this fx equal to limit n tending to infinite, and basically in the standard form of a limit of a sum, what we want is we want to try to form it as a function of r by n. So let's see if we are able to get that up. So here, numerator we have n power n. Then for all these terms, if I take n common from all the factors, so what I'll be having is n common. So we are left with x by n plus 1, then x by n plus 1 by 2, and so on till x by n plus 1 by n. And since you have taken n common from each of the factors, and here we have having n factors, so n raised to the power n is the common thing. All right. Okay. Now in the denominator portion, n factorial is written, and we are going to take n square common from each of the factors from this one, and we are having n brackets. So we will be having n square power n common, and in the brackets we are left with x by n square plus 1. Second bracket we are having x by n square plus 1 by 2 square. 1 by 4 I can write as a square of 1 by 2. And like that it will continue till x by n whole square plus 1 by n square, and whole raised to the power we have x by n. Now you can see that we have actually formed this x by n, which I don't want. I want r by n. And here we are having 1 by 2 till 1 by n. So one thing I can do over here, and that is I can rewrite this as this is n power n into n power n. And now here in the first bracket, it's all fine, right? It is x by n plus 1. Okay, let it be. Second bracket, if I'll multiply by 2, in the second bracket only, if I'm multiplying by 2, I will be getting 2x by n plus 2 by 2, which is 1. In the third bracket, it would be x by n plus 1 by 3. So here in this third bracket, if I multiply by 3, so I will be having 3x by n plus 3 by 3, which is n. Similarly, in the fourth bracket, I'll multiply by 4. Okay. And similarly, in the last bracket, I'll multiply by n. So it is nx by n plus n by n, which is 1. So what I have done is I have multiplied 2, 3, 4 till n. So multiplying 2 to n, is it n factorial? Yes. So I have to divide by n factorial. As I have already multiplied by n factorial, I have to divide by n factorial. Okay. 1 n factorial was already there. 1 n factorial I have introduced by multiplying and dividing. Okay. Now we have n square power n. In the denominator terms, similar kind of thing is there, but with square. So what I'll be doing is I'll multiply with 2 square, 3 square till n square. And same thing what I have to do is we have to divide. So basically we are going to multiply divide by n factorial. Okay, square. So square of n factorial, we are multiplying dividing. So here n factorial square, and in the division I will include in the brackets, that is x by n square plus 1. Second, 2x by n square plus 1. And in the last one, nx by n square plus 1 whole x by n. Now here you can see that this n power n got cancelled and this n factorial square also got cancelled. So now we are left with this fx equal to limit n tending to infinity, and the expression now is in the kind of form which we are expecting. So I'll write it as product of r x by n plus 1, where this value of r starts from 1 and is till n, yeah? And divided by, this is the product x by n, rx by n whole square plus 1, and here also the value of r starts from 1 till n, and whole we have raised to the power x by n. Now we want to take log here because everything is in product. We have to convert into sigma. So for converting to sigma, we are taking log on both the sides. So ln fx equal to limit n tending to infinite. Upon taking log, the power x by n is coming as a coefficient, and we are left with this ln of pi r equals to 1 to n ln we are having. So this is r by rx by n plus 1 divided by product rx by n whole square plus 1. Okay, now so this is like ln of a by b. ln of a by b is ln a minus ln b. Let's apply that property here. So this we can rewrite it as ln fx equal to limit n tending to infinite x by n and ln pi rx by n plus 1 from r equal to 1 to n minus ln pi rx by n whole square plus 1. The same limit is on both the pi r equal to 1 to n. Now, if you are having so many products in a ln, so you can write it as like ln a into b. Let me write for you. So as we know that ln a into b is equal to ln a plus ln b. So basically we can convert that product into sigma out of that ln. So we can rewrite it as limit n tending to infinite x by n. And now this will be converted to sigma ln rx by n plus 1. R is from 1 to n. And here same thing, minus x by n. That x by n is multiplied to both the terms actually. So x by n ln, we are applying sigma rx by n whole square plus 1. And this sigma is from r equal to 1 to n. Okay. So now if we do that substitution, limit as a sum substitution, that is here r by n, if you assume it as t, so this 1 by n will be equal to dt. So this so this now expression is converting into integration. So this will be integral, x will be remaining, and this is integral ln x t plus 1 dt, and the limits starts from r equal to 1 by n, and n is tending to infinity, means 1 by infinity, which is 0, and here n by n means 1, minus here also the same thing, x integral ln here x and t square plus 1 dt, and the limits are same, 0 to 1. Now if you see here, you are integrating in dt like in terms of t, and you have one extra term like x is there, and we can see that x we have as a linear. So if I substitute that x t equal to some other variable, let's say let xt equal to, if I am assuming u, so dt, x dt will be equal to du. So this x into dt will be converting to du. So that will be more simplified here. So integral ln u plus 1 du. All right. So, and the limits, when the t is 0 here, when t is 0, the value of u will be 0. So initial limit is 0. And final limit when t is 1. So if t is 1, u will be x. So 0 to x minus, same here, limits will be same now. 0 to x ln u square plus 1 du. All right. This is your ln fx. Now, this is something simplified form of the given function. Now, in the options, what they are asking? In the options, they are asking, in the first option, they are asking to compare the values of the function. Second, also same thing. So for first and second, I can see that they are asking for the comparison of the values of a function. So if we get to know that whether the function is increasing or decreasing in that particular interval, we will be able to say that whether it is correct or not. So for increasing, decreasing, we have to differentiate this function. So ln fx derivative is 1 by fx, and the derivative of fx is f dash x equal to, here you have to apply that Leibniz rule. So putting the value ln x plus 1, and the derivative of x is 1, minus 0 means 0, minus ln x square plus 1. So again, we can rewrite this as ln 1 plus x divided by 1 plus x square, and this is your f dash x divided by fx. All right. Now here, just try to think that this was your ln fx relation. Okay. So if you have to write fx value from here, so fx would be that ln, if you remove, that everything on the right hand side will be in the power of e. Okay. What I'm saying is, from here, if you want to write fx, fx would be e power this all integral. Whatever is the value of all the integral, e raised to the power anything is positive. Okay. So this fx is actually positive somehow. Correct? Okay. So this fx is positive actually. This is positive. All right. Why am I thinking this? Because we have to see what is the derivative. Is it positive or negative? Whether it is increasing or decreasing. All right. Now coming to the right hand portion. This. Now ln of anything. You know the graph of ln of anything, right? Ln theta base e, you have the graph like this. This is the graph of ln base e. This is 1 comma 0. So anything if you put greater than 1, it is positive. Anything if you put less than 1, it is negative. So now if I assume that this 1 plus x divided by 1 plus x square is greater than 1, if I am assuming, then what will be ln of that thing? So if I am putting greater than 1, so definitely this is giving me positive values. Okay, now. So then this entire thing will be positive. And if this is positive and this is positive, then can we say that f dash x is also positive? Yes. And then we can say that fx is increasing. Fx is increasing. But fx is increasing for what value of x? That we will get from here. So cross multiplying. Why I have cross multiplied? Because 1 plus x square is a positive quantity. So I can cross multiply here. So I have got this x square minus x is less than 0. Taking x common, I am left with x minus 1 less than 0. That gives us 0 and 1. Plus minus plus. So for negative means this is the answer, 0 to 1. So from here, I am getting the value of x as 0 to 1. So fx is increasing for all x belonging to 0 to 1. Okay, so this fx is increasing in 0 to 1. Yes. So if fx is increasing in 0 to 1, this is 0 to 1. At 0, I don't know what the value is, but something, the function is increasing till 1 from 0. Now, if you see in the options, the first option is f of 1 by 2 is greater than equal to 1. So 1 by 2 will be somewhere here. 1 by 2. In the first option, they are saying f of 1 by 2 is greater than equal to f of 1. No, the function is increasing in 0 to 1. So f at 1, the value will be bigger as compared to 1 by 2. But they have written opposite, so option A is completely wrong. Coming to option B. Option B is given that f of 1 by 3 is less than equal to 2 by 3. So f of 1 by 3 is less than f of 2 by 3. Yes, correct only. So if you see this 1 by 3 is smaller as compared to 2 by 3. So their output will also be smaller as compared to 2 by 3. All right. So this is the correct option. Okay, option B is correct. Now coming to option C and D. So option C is given as f dash 2 is less than or equal to 0. Let's see what will be f dash 2. So already we have calculated that f dash x is increasing only when x is less than 1. So what happens for greater than 1? Already you have seen that for greater than 1, f dash will be negative. Correct now. So f dash x is negative for all x greater than 1. And in that option, they have given that third option, f dash 2 is less than equal to 0. F dash 2 is less than or equal to 0, which is absolutely correct. Now coming to option D. So option D is here. Option D, f dash 3 by 3. F dash 3 by f3 is greater than or equal to f dash 2 by f of 2. Now let's check this option whether it is correct or not. So for comparing functions, like comparing this expressions, what we can rewrite it as f dash 3 divided by f of 3 minus f dash 2 divided by f of 2 is greater than equal to 0. So now we have to check whether this is greater than equal to 0 or not. Okay, let's try. So already we have seen that we have got this expression f dash x by x, this expression. F dash x by x, fx is f dash x by fx. We have ln x 1 plus x divided by 1 plus x square. So from here, f dash 3 divided by f of 3 will be ln 3 plus 1 4 divided by 9 plus 1 10, and f dash 2 divided by f of 2 will be ln 2 plus 1 3 divided by 4 plus 1 5. Now we have to subtract this. So f dash 3 divided by f of 3 minus f dash 2 divided by f of 2 will be equal to ln 4 by 10. We can write 2 by 5 minus ln 3 by 5. You know that ln a minus ln b is ln a by b. So ln a divided by b. So which is ln of 2 by 3. Now 2 by 3 is less than 1. And if it is less than 1, that ln value will be negative. So it will be negative. So what we got is, in the options, they were asking whether it should be greater than equal to 0. But what we get, we have got less than 0, which means that option D is not correct. So finally, options B and C. Option B and C are the final correct answers here. B and C. A and D are the wrong ones. So actually, this looks like a simple question while I'm solving right now, but you can see that students have faced a lot of difficulty, as only 1% student gave the correct answer, and unattempted, like 80% left this question itself, because reducing it to that form, reducing it to this step, till this step, is very difficult. Once you get to this step, we can differentiate and we can get like comparisons. So to solve till here patiently under pressure in the exams of JEE Advanced is not that easy actually. All right. So hopefully you have enjoyed the session. Thank you. See you in the next one.